All right, let's take a look at our AP tester trio. So this is talking about transformations. Okay, we're transforming through a function. Maybe in this case, we're transforming from Celsius degrees into Fahrenheit degrees. So we need to, since we don't have all the individual pieces of data to recalibrate every one and then compute, we need to know how are these measures of center and spread affected by this function. So here I summarized it here. So remember this, that measures of center, like your mean and your median. Okay, so remember that little ball that I had? So here I'll just do it like this. Okay, so remember the ball that I had? Okay, so if we had this, then the measure of center is affected by adding and subtracting and multiplying and dividing. Okay, so it does stretch out or get smaller. So multiplying and dividing. So measures of center is affected by all those things. But measure of spread, so if this is my spread, then here I've got adding, subtracting is not affected how varied and how spread out this is. But if I multiplied it or divided it and got it smaller, then that does affect the spread. Okay, so I had done that with that ball, remember? So standard deviation and IQR are only affected by multiplication and division. So how is this affected? So the mean is staying the same. I mean, the mean on every single one of these was the same. And you know what? These are not good answer choices because I'm surprised one of the answer choices is not 32.54. Okay, so because the standard deviation is 0.3. Well, if you plugged this 0.3 into here, then you're going to do your 0.3 times your 1.8, and that's 0.54. But the number one mistake people make is that they then add 32. So, but you're not supposed to do that for spread. Remember, spread, do not add the 32. The adding of the 32 will not change the spread. So anyway, it was C. Now, here is a good one. We have 3 different brands of candy, X, Y, and Z. And so which of these statements is must be true? So I can tell you what's going to happen in here. So I knew before I even looked at this problem the kind of things that were going to get thrown at you to see if you knew. So they're going to talk about not just the proportion, because this is relative frequency. That's percentages of data. Well, that's percent of brand X. Well, how many brand X items are there? Is there just 10 items of brand X? And then here's brand Y. Well, how many is that? Is there maybe 100 pieces of data in that bar? How about brand Z? Does it have 1,000 pieces of data? Don't know. So the key is you do not know how many is represented in each one of these brands. So you cannot compare brand to brand when you're comparing the number of items. Now, I can compare percentages from brand to brand, but not how many, not the number. And that actually is what statements C, D, and E do. They compare the number of candies from one brand to another. So C's out, D is saying the same from brand X to brand Y, and E is saying the blue candies is brand Z is equal to the sum of the other 2 brands. Okay? No. So C, D, and E are out because they are number of items from brand to brand, and we don't know how many. All right, so that leaves us with A and B. A is easy to go out because it says a higher proportion, more green than red in the X. you can compare within just one brand. So I can compare the red and the green in brand X. And I can compare as B does in brand Y. Here's more red ones to the green ones. Yes, that's true. Okay. These ones look like, what is that, 40 and then 35. So there's more red. Okay. And let's see our last one. Similar idea, but it also just gave specific information about ranges. It saw if you remembered that. Also talked about where these quartiles were, medians, IQRs, that kind of stuff. So which one of these cannot be justified? Okay, so again, another one of those not. The range is equal for both of them, okay, because they both go from 20 to 60. So the ranges are 40 for both of them. Also, the IQRs are the same. The IQRs are 15 for both of them. Now, the statement C says the median for one is less than the median for two. And yes, that's correct because you can see that the median of 35 for data set one and the median of 45 for data set two. Now, here is where we have an issue. And we'll go ahead and take a look at E. E is comparing the 75%. See, so this is 75% of data set 2 is above this bottom 50% of data set 1. Yes. So again, this is your recognition of what's in the quartiles. Okay? So what's wrong with D? Because it's talking about the number of data points. We don't know how many. This one could have 10 items and this one could have 10,000. We don't know. We don't know how many, so we can't compare the numbers. All right, there's that. Now, this summary page is good because it kind of goes over the number of samples or populations, okay, and the number of variables. Samples, variables. Then it gives an example, okay, example of what that is in context, and your hypothesis statements, okay. How you get, what's different about these is like your degrees of freedom, how those are different. Okay, degrees of freedom, how those are different. How you do your conditions for both of them. Here, again, you can find that expected without the use of the calculator. If you didn't have all the numbers in the matrix, you can find a cell's expected value by doing the row total times column total over total total. And then it talks about how to do this in your calculator. The calculator on this was in the list because it was just a single dimension, one list of observed. But for both the homogeneity and the independence, we have multi-dimensions of observed, so that's why we had to use the matrix. All right. And finally, standardized residuals. We're using this more or less if you reject HO, okay, so if you reject the null hypothesis and they want more information, more detailed information about what's happening. How, positive residuals, what you got is more than what was expected. Negative residual, what you got was less than what was expected to happen. Okay? So there we have that standardized residual idea. Okay, so there it is, all together, succinct, the different kinds of chi-squared values. Okay, so good luck to you on your Unit 9 quiz. We are not testing this until we do it with the Unit 10. We will do those two together. All right, so I will see you tomorrow for your quiz.